So welcome Level 2 physicists to our next lesson in Level 2 mechanics, that of horizontal projectiles. So we've looked at freefall, which is motion in the y direction when it comes to a projectile being dropped. Now we're going to incorporate the direction in the horizontal. Okay, so in order to do that, you have to reacquaint yourselves with these four wonderful kinematic equations, plug in numbers to get values, understand those values to make conclusions. So before we do that, here's a kind of a thought experiment. You have two basketballs. The first basketball you just drop, it's in free fall. The second basketball you are going to push off at a constant velocity of 10 meters per second. So which ball will have more air time? So pause the video now and have a little think about that. Okay, so you should have worked out that they should actually have the same air time. They should be in the air at exactly the same time, or for exactly the same time. And an experiment that illustrates this is the bullet fired versus bullet dropped experiment. So essentially you have a pistol and you drop a bullet, and at the same time you are shooting a bullet at a constant velocity, and you can determine that the time the bullet is in the air is identical for both cases. Seems counterintuitive, but when you look at the physics, it all makes sense. So going back to our airtime example, you can see that for our first ball, which is only dropped, is only moving in the y direction, whereas our second ball is not only moving in the y direction, but because of that constant velocity in the x direction, it's also moving in the x direction. Okay, so even though it has a higher initial velocity, it actually has to travel a further distance because of those two components are working in combination. Yes, a vector. So that's what it means there. So basically for the first example, you've only got to consider the y component, the distance in the y direction, whereas for the second example, you've got to consider not only the direction the ball is moving in the y, but also the direction the ball is moving in the x at a constant velocity. So what is the impact velocity and the angle? Well, you can use trigonometry. Okay, so you know that the initial velocity of the ball in the second example is going to be 10 meters per second. You can use the wonders of the kinematic equations to determine that the ball is going to have a final velocity, at least in the y direction, of 22.2 meters per second. So to work out the final velocity when you're considering both the x and y component, you use the vector, use a bit of trigonometry, and find there's 24.3 meters per second. Then to work out the angle, all you have to do is recognize that it's going to be tan theta equals 22.2 divided by 10. Okay, so that's going to be the opposite over the adjacent. Then theta will be the inverse tan of 22.2 divided by 10. So theta will equal 65.8 degrees. And that is all you need to really know around the kinematics of projectile motion on the horizontal direction